All right, welcome to this next lesson on conditional probability. Now, conditional probability is best summed up with this little graphic here, which is also the way we write it. So it's written as with brackets, this vertical line, which we've been using in functions to mean given, and it still means given here, but it has a slightly different context. All right, so it says that B is the event that may or may not occur, and A is the event that's already happened. And we read it as in, what are the chances of B happening given that A has happened? Okay, so obviously this changes the sample space and the probability from the total of the experiment into a smaller subset. And I'll show you what I mean. So this question here says, suppose we roll a fair die and event A is rolling a 6. So we have this circle here which is rolling a 6. Event B is rolling an even number. Now you can see that 6 is also an even number. So B is covering circle A. So there's A, there's B. Event B could have 2 or 4 in it. All right? Then the leftovers of rolling this die are outside. So we could have 1, 3, or 5. All right? What is the probability of rolling a 6? Rolling a 6 given that the even number was rolled. So I've got 6 given that it's even. Okay, so let's have a look at individual probabilities first. So what are the chances of rolling a 6? Obviously the chances of rolling a 6 are 1 in 6. The chances of rolling an even number is 3 out of 6, because there are 2, 4, or 6. 3 out of 6, that's the same as a half. All right, so we have these different probabilities. However, what happens if we rolled an even number? All right, so we have a 3 in 6 chance of rolling an even number. So out of that 3, one of them is a 6. So what are my chances of rolling a 6 if I've already rolled an even number? All right, so I have 3 possibilities if I've rolled an even number. They are 2, 4, or 6. One of those 3 is my 6. So my chances of rolling a 6 given that I rolled an even number is 1 out of 3. Okay, so the subset has changed. The sample space has changed. It's no longer the entire sample space. It's now the sample space of the event that's already happened. All right, and we're looking for the crossover in the first event into the event that's already happened. Okay, so it changes the denominator in this fraction, and it's conditional on the second event happening. Okay, now often or sometimes the questions don't make sense in terms of a picture, but we've just got to plug through them. All right, so here's another example of a question. We have this one here. I'll move that up. Move this up. In Stephen's class, 12 students study Chinese, 20 study French, and 8 study both. All right, so we'll draw a Venn diagram. I will name them as French or Chinese. Okay, so we're interested in both first because that's the intersection. 12 in the Chinese circle, which means there's 4 there, and 20 in the French circle, which means there's 12 there. Okay, now the total sample space is the leftovers. Doesn't tell us what the leftovers are, so we'll just leave it like that. Now it says, given that a student in the class studies Chinese, what is the chance they also study French? So this is the PR of French given Chinese. Okay, so the first event written is the last event mentioned because it said, given that they study Chinese. So this is the given that, and this is what we're looking for. All right, so given they study Chinese, so now studying Chinese, there are 12 students. So our denominator is 12. What is the chance they also study French? In which case there are 8. So our numerator is 8. 8 out of 12 is also the same as 2 out of 3. All right, so our PR equals 2 out of 3. All right, so our sample size has changed, or our sample space has changed. Question B, it says, given that a student studies French, what is the chance they also study Chinese? Now this might seem a bit of a no-brainer. You're already thinking to yourself, surely it's 2 out of 3. But look at the circle of French. This is our denominator. It's 20. Previously, it was 12. So it's not going to be the same fraction. All right, so what's the crossover of Chinese into French? And that is 8. Numerator stayed the same, denominator changed, because the first event, which was studying French or studying Chinese, had different sample sizes. All right, so 8 out of 20 is the same as 2 out of 5. Okay, so you can see here that conditional probability is not reversible. All right, you can't say A given B is the same as B given A. All right, so we have to be very careful when reading the questions and making sure we match up the information we've been asked to find. All right, so let's look at another example. This one here says that 500 people were questioned and classified according to age and whether or not they regularly use social media. The results are shown. Do you use it? Yes, no, and your age. Yes, no, and your age. Okay, so let's have a look at the question. It says, one person is chosen at random from the 500. Given the selected person is less than 25 years, so our given that is less than 25. What is the probability they regularly use social media? So it's yes, given they're less than 25 years old. All right, so the given that is the sample space. So we have less than 25 years. There are 240 people less than 25 years. So our denominator is 240. Now the yes out of that is 200, and that is our fraction that we're looking at. So it simplifies down to 5/6. So I have a 5 in 6 chance of picking someone who answered yes, given that I've chosen an under 25-year-old. All right, so there is a bit of a formula to calculate this if the probabilities are a little bit not easy to see. So I'll show you that formula now. All right, so here comes the formula. Is it this one? Here we go. There we go. So the formula says that the probability of A given B is equal to the intersection of A and B divided by B, so long as B doesn't equal 0. And you have to say that because we're dividing by 0, and if you divide by 0, it's undefined. So that's just a little caveat that it will always be there. All right, so A intersection B divided by B. Let's move back up here to this previous question and have a look. So A intersection B divided by B. Now remember this is a Carnot map. A intersection B was this one. So our fraction here was 200 out of 500 because we're looking at pure probability of that subset divided by probability of B, and chance of B is this one here, 240 out of 500. Now if you remember how to divide by fractions, this will turn into 200 out of 500 multiplied by 500 out of 240, and that will simplify out and we'll be left with 200 out of 240, which was just what we had there. All right, so this formula needs to be written into your books, this conditional formula, and this formula can be rearranged to provide you the formula for intersection, which is just conditional times B, which is just moving this denominator across to the other side, which will give you the numerator there. All right, so it's just a rearrangement of the same kind of thing. All right, so write this formula into your book, and this one's called the multiplication rule. As you might remember previously, we had the addition rule. All right, we'll finish off with 2 examples, and then I'll show you the formula for something called the total law of probability, which is just a fancy way of showing you what should be pretty common sense. All right, so here's the question. In a particular school, 55% of students are male and 45% are female. Of the male, 13% say mathematics is their favourite subject, while of the female, 18% prefer mathematics. Find the chance that these 2 things. All right, so let's first of all, let's spell out the information given to us. So we have PR of a male is 0.55. I have PR of a female is 0.45. I have PR, now let's think about this, 13% of males, so this is, say mathematics is their favourite subject, so they prefer maths given their male is 0.13. and the chance that a female prefers maths is 0.18. All right. Now, you might have noticed that male to female adds up to 1, but these conditional ones don't add up to make 1 or even close to, because they're conditional. They're a combination of other probabilities. All right. So how can I use this information to find the chance that a random prefers mathematics and is female? So this is, I'm looking for female intersection with prefers mathematics, P given F. Well, actually, no, I won't write it like that. I'll just say prefers. Female and prefers. So I know the chance that they prefer if they're female, but I don't know the total chance in the whole pool of finding one of those females. All right, so this is where we can flip back to our little formula down here, which is this one. All right, so I know I want to find the intersection, and I'm given this and this. So I combine them like so. So P given F equals PR F intersection P over PR F. All right, so now just plug in the parts that I do know. So I have 0.18 equals PR F intersection P over 0.45. Now, how do I find this numerator? Well, I multiply the denominator to the other side. So 0.45 multiplied by 0.18 equals the intersection, F intersection P. And you will find that this number is 0.081 equals the intersection. So I have a 0.081 chance of finding a female who prefers maths if I just chose a random student from the entire school, right, which is a very small chance. What about the chance of finding a male who prefers maths? Well, we do a very similar, exactly the same thing with the different numbers. So we have our formula written here, P given male equals PR male intersection P over PR male. So my chance here was 0.13 equals the intersection, which is what I'm trying to find, over 0.55. Multiply those two together across the bottom and you end up with 0.0715 is my chance of finding a male who prefers maths from the entire school. Now you might notice that this chance here is a lot, or a little bit smaller than this chance here, which is a bit surprising given that there were more males who were in the school, not preferred maths, because they had a smaller percentage who preferred maths, right? So a smaller percentage, but a bigger ones who preferred for female, all right? So that's part one. Now I'm going to show you part two, and it leads into the total law of total law of probability. All right, so here's part two, where it says, using the information from example 22, construct a tree diagram and use it to determine a few things. So first steps first, we have two events. We could be male or female. We could also prefer maths or not prefer maths, and it's the same for the females. All right, so I have my prefer and not prefer. Now, what I can also write on here is the weightings. So there was a 0.55 male, 0.45 female. For prefer, it was 0.18 for the females and 0.13 for the males, which means that the not prefer for the males was 0.87 and the not prefer for the females was 0.82. Okay, now what you might notice here is that each pair of arms, prefer, not prefer, adds to 1. Prefer, not prefer adds to 1. The male, female adds to 1. So we're looking at this idea that probability always adds to 1, different, so long as it's the event and its complement. Okay, so now this arm here, let's have a look at it. This one here, this one is P given M. This one is not P given M. This one is P given F. And the bottom one is not P given F. All right, so now we can calculate the intersections. If I was to multiply the male arm with this conditional arm, I would be calculating P intersection M, as you saw in the question above. if I was to multiply the male arm with the not prefer, I would be calculating not P given M, intersection M. And similar stories for the females. We did that one above, and this one would be not prefer for the females. All right, so there's a few things we can calculate on these tree diagrams. So let's have a look at the question again. Find the probability that a student selected is female and does not prefer mathematics. All right, so female and does not prefer mathematics. We're obviously looking for this arm here. So this arm is going to be 0.45 multiplied by 0.82, and that's going to give us an answer of 0.369. So I have a 0.369 chance that I select a student at random, it'll be female and doesn't prefer maths. Okay. Now, B, find the overall percentage of students who prefer maths. So we know it's made up of two parts. Overall percentage implies that we're looking for all the females who prefer maths and all the males who prefer maths. Okay. So the chance that someone prefers maths is made up of, we have prefers maths with females combined with prefers maths and is male. All right, so I need to know both of those things. So prefers maths and is female, we answered in the previous question, it was 0.081. Prefers maths and is male, we answered in the previous question, it was 0.0715. All right, now what we can just do with this union means combination, so we just add them together. And we end up with a 0.1525 chance that's a chance, so we can convert it into a percentage, that equals 15% of students prefer maths overall, combining both males and females. Now you notice that I used the word and when I talked about overall, but I used the symbol for union, which the correct wording should be or. And what this question has actually asked us is, what are my chances in the total school, if I picked a student at random, of pulling someone who prefers maths, whether it's male or female? So you can see there that I used the wrong words, but it means the same thing. Okay, so this leads us to what's called the total law of probability. I'm just bringing up the picture to show you. All right, and it's just a little formula. It says that in the case of two events A and B, chance of A is multiply the conditional A given B by B, and the conditional of A given not B by not B, and you'll get the chance of A. Now, it might not make a lot of sense, but let's just have a quick look at it. So A given B by PRB, and I won't show you this for both parts, I'll just show you for one part and it'll work the same way. Now remember that formula there, A given B, we could substitute this in over PRB, and if we then multiply it by PRB, you'll see that they just cancel out, and I'm left with PRA union B. Now A intersection B is that middle part of a Venn diagram, but if I want to find my chance of A, I need the rest of the crescent shape of the A circle, so I need to add in the not B part. So this will do the same thing. If I simplified this out, I would end up with the top line being A intersection not B. And if you remember back to our Venn diagram, that is the crescent part of the A circle, and that's the intersection part of the A circle. So together, that must mean the total A circle has been selected. All right, so this is the law of total probability. It's just a manipulation of the different areas and the different complements combined so that we can use partial results to calculate full probability. All right, so write that into your book as well, and then go and have a go at the questions.